So today we're going to talk about Lesson 5, graphing square roots and cube root functions. But before we begin, I want to make sure you guys have had a chance to work on the group warm-up. If you haven't done so already, you guys can pause the video because we're going to go over the answers together right now before we start on the new notes. In our group warm-up, they're asking us to graph the following function on the coordinate plane. Then they want us to state the domain and range of the function. So in letter A, if you notice, we have f of x is equal to negative x squared plus 6. And if you remember correctly, x squared is our leading, our degree is 2, our leading coefficient is negative 1. But we have a quadratic function here, and we all know that quadratic functions have graphs that look like parabolas. And that negative in front of our x squared is basically telling us that our parabola is going to be pointing downward. So we're going to plot some points here and figure out what exactly we're going to be graphing so that we have an actual graph over here on the right hand side to look at. So f of x is just fancy for y, so if I just take f of x and I replace it with y equals negative x squared plus 6 is the function that we're graphing. So I'm going to pick a couple points to the left and to the right of 0 and see where that graph or parabola ends up on our coordinate plane. So I'm going to pick the points negative 2, negative 1, 0, 1, and 2 to plug into my equation and see what I get out for my y values. So if I plug that in, my y value is going to be equal to negative 2 squared plus 6. Well, negative 2 squared is 4. Negative 4 plus 6 gives me 2. If I plug in negative 1, if I take negative 1 squared plus 6, negative 1 squared is 1, but negative out in front still applies to that 1, so I get negative 1 plus 6, which gives me 5. If I plug in 0, 0 squared is obviously 0, negative 0, there's just 0, so plus 6 gives me 6. If I plug in 1, negative, and then 1, it becomes squared. 1 squared is positive 1, so that becomes negative 1 with my negative on the outside. Negative 1 plus 6 gives me 5. And if I plug in 2 squared gives me 4. Negative 4 plus 6 gives me 2. And because I know my quadratics or my parabolas have the axis of symmetry, so they're symmetrical on both sides, it makes sense that my left-hand side and right-hand side have the same numbers. So if I plot these points, at negative 2, I'm at 2. At negative 1, I'm at 5. At 0, I'm at 6. So 2, 4, 6. At 1, I'm at 5. And at 2, I'm at positive 2. So if I take my points and I connect them with my graph, I get a parabola that is pointing downwards, which makes sense since my leading exponent is 2, so I have x squared, and my leading coefficient is negative. In this case, remember I have to still find my domain and range. My domain deals with the list of x values that work for this equation. My range is my list of y values that I get back out. If I look at my graph, can I plug in negative numbers into my equation? Absolutely. Can I plug in 0? Absolutely. And can I plug in positive values? Absolutely. So my range deals with my x values only, and because my graph spans both positive, negative, and 0 for my x's, my domain is going to be all reals. So all real numbers for my domain. And if I look at my graph here, what values can I get out, which means I'm looking at my y. So in my graph at 6, I have points that span my y axis in the negative direction starting at 6, but I have nothing spanning y in the positive direction. So in this case, my range is going to be my y values less than or equal to 6 because I have no y values above 6. So 6 and below is my range.